name is Ravi Kanitkar, and today I'd like to speak about FRP anchors. FRP anchors and the concept of anchoring FRP have been in use for quite a while, and we've all seen pictures like these shown on this slide. FRP anchors can come in many different forms. The most common form is a bundled fiber anchor. They can also come in the form of long ropes which can be cut as needed in the field. We've been working with a precured anchor with a precured dowel to be installed in the concrete and free fibers that can be saturated and installed in the field. So today I'd like to talk about the conventional bundled fiber anchors or floppy anchors and the precured anchors. The impetus for trying to do something different with anchors came about in 2008 with this bridge project, where cruciform-shaped columns had to be strengthened for shear. The concern was that the FRP would debond from the concrete in the reentrant corners. Scale testing was done at Washington State University, where anchors were installed in the corners, like so and like shown here. And the tests showed that the strengthened columns behaved as expected, with strains in the FRP greater than or equal to the 0.004 strain level specified by ACI 440.2R. Given the success of the testing, it was decided that all the columns would then be retrofitted with FRP, and the FRP will be anchored in the corners. To make the FRP anchors, the contractor opted to use strips of FRP of the right width to get the right fiber content in the anchors, rather than using bundled fibers. So the strips were cut to the right width and length, pinched down in the middle, bent, and then inserted into the hole with a tool. Obviously, this was done after the fibers had been saturated. Nearly 5,000 or 6,000 of such anchors were installed on this project. But during the process, it became clear that installing such anchors is quite difficult, and led to the thought process that maybe there was a better way to do things. On another project, we looked at anchors for anchoring down ends of FRP on shear walls, and the intent was to see how much the anchors helped. And you can see that debonding of the unanchored FRP occurred instantaneously, while for anchored FRP, not only was the debonding delayed, but there was a residual strength, which was provided by the anchor in the concrete. So it showed that FRP anchors are indeed very valuable for designers. But what about some of those installation issues? Now we're starting to see more and more details where FRP anchors are used. For example, a common detail is to continue FRP across a slab or a beam with anchors, through anchors in this case, or to connect FRP at the bottom of a column or wall into the foundation using doweled FRP. This gives rise to details like these. So how are floppy or bundled fiber anchors saturated and installed in the field? The first thing is to saturate them, which is often done by throwing these anchors into a bucket of resin. They're pulled out, laid on a plastic sheet, and the resin is slowly worked into the fibers carefully. The excess resin is then squeegeed out. Sometimes these anchors are now weighed to make sure the right amount of resin is in the anchor. And then the anchors are installed, as shown in this little video. These 2x2 concrete blocks were created for this demonstration, and the installation is being done by a reputable, experienced contractor in the San Francisco Bay Area. So we're using a screwdriver. He is pushing the anchor into the hole. Once it's in all the way, the screwdriver or any similar tool would then have to be removed. And it has to be done carefully. As you see, as you pull it out, the anchor fibers want to pull right back out with it. And this tendency to pull back out gets worse as the tool gets sticky after multiple anchor installations. So this means that there are some drawbacks in how currently the FRP anchors are being installed. The fibers can get damaged or twisted, which could be a quality control issue. The anchors may be difficult to saturate and install, a quality assurance issue maybe. The embedment of the anchors is difficult to estimate, so it's an inspection issue. And then drawings often call out anchor diameters, and with bundled fiber anchors, it's difficult, if not impossible, to verify that the appropriate anchor size is being provided. Some manufacturers use weight as a measure, but drawings do call out diameters, so there's a disconnect. And such drawbacks can lead to adverse effects on design intent, field inspection, and definitely on productivity. This brings up a few questions. Do the installation and QA/QC issues that we just saw affect or compromise structural performance? The answer is likely yes, but we don't know by how much. Should designers and owners accept that their designs can have so much variability because of the installation issues with bundled FRP anchors? We would not accept so much variability for the materials. So shouldn't FRP anchors at least have the same level of QA/QC as regular FRP? Shouldn't there be some QA/QC requirements? We've made so much progress with post-installed metallic adhesive anchors. Are there any similarities? Can we learn from metal anchor behaviors? And then finally, is there a better way forward for FRP anchors? The answers are yes, and so let's look at some of them. As I said earlier, we've been playing with precured dowel FRP anchors. So the concept is to take one end of the FRP anchor and pre-saturate it, precure it. This part goes into the concrete with adhesive. The goal of this process is to try to take the guesswork out of design, fabrication, installation, testing, and QA/QC. So more specifically, the goals are create consistent and standardized shop fabricated anchors. So every anchor is the same. Have a precured dowel end for installation into the concrete. Maybe use a special aggregate to enhance the bond. Make sure this part of the anchor is well tested. Maybe design some tools and implements to completely saturate the fibers and make sure they're nice and straight in the field after saturation. Make these anchors easy to inspect, and then if possible, allow high production rates so that contractors can install more with high levels of QA/QC. We've done a fair amount of testing with these precured anchors. As far as anchor pullout is concerned, you can see that they behave very similar to metal anchors. When there's a shallow embedment depth, what you get is a shallow cone failure, just like you would for steel anchors. As the anchor gets longer, you start to get these shallow cones with debonding in the lower part of the anchor. Again, very similar to metallic anchors. You can plot the performance of these anchors in concrete. So this is for a 3/8 inch anchor with a 4-inch embedment. And you get nice tight plots showing that they're quite consistent in their behavior. This horizontal line here is based on some design equations for FRP anchors in concrete put together by S. Kim and Scott Smith in a paper in 2010. And these equations shown here can be used to fully design the FRP anchor embedment in concrete. So now it tells us that we have a way to design the concrete anchor portion What about the portion that goes onto the FRP, the splay portion? We've done about 64 tests with different size splays, where the splay sizes or lengths range from 4 inches to 8 inches. We use steel plates so as to remove concrete strength from the equation or from the behavior, and tested FRP to FRP splays. The results here are plotted in terms of bond stress versus the test number. It can be seen that for smaller splays, or for the 4-inch long splays, we get high bond stresses. But as the splays start to go from 6 inches to 8 inches, there's a certain uniformity of bond stress around the 800 to 1000 psi range. So using a lower bound value, we've developed an equation for designing the splay area required between an anchor and FRP. And this is based on the shear bond strength of epoxy, which can be easily measured and reported by a manufacturer. The results of the above two tests can then be consolidated into a table like shown here, where for an anchor diameter and embedment depth, depending on the concrete strength, you can find the pull-out capacity and then find the splay needed to develop that pull-out capacity. We've also gone ahead and developed a design methodology for FRP anchors with some researchers listed here. This has been now put together in a paper that was published in Composite Structures earlier this year. The result of this design methodology is a flow chart that can be used to design anchors. You can start with the force required in an anchor or required by an anchor to resist, and end up with a fully designed anchor with possibility to optimize the anchor number and size along the process. We're continuing to test these dowel anchors in a variety of different applications. For example, this is a column which is being strengthened for flexure, and the vertical FRP is being tied down into the foundation with dowel anchors. This testing for a beam with flexural FRP is being done at Kansas State University. So we've seen how floppy anchors are saturated and installed. How about the precured anchors? This little video shows you the process. So you take a precured anchor, pull off the protective sheet. You open up the fibers and you saturate them, starting with the precured end in this specially designed bath for saturating the anchors. Once there is adequate resin in the fibers, you pull the anchor through a specially designed two-stage die. The die is designed to ensure that there is adequate saturation not only at the precured end, but also in the loose fibers. The anchor then can simply be installed into a hole pre-filled with resin, and you can see the process is very similar to a metallic anchor. No tools are needed. This 14-inch embedment depth was quickly achieved for this particular anchor. And as you can see, the anchor is saturated and installed in just a few minutes. And you can build in a lot of quality control and quality assurance into the process. The quality control doesn't stop at the product level, and so we've been looking at some of the older samples we made in 2017. These were rejected based on some weight criteria that we have, and when we cut them open, we found that there are dry fibers in the middle. Since then, we've been refining the process of saturating the precured ends of our anchors, and the new anchors, again made in the 2-inch by 2-inch concrete blocks, show that we've achieved near full saturation of the fibers in the anchors. What do you think the floppy anchors installed similarly would look like? As you can see, it is very possible to have lots of dry fibers, even at the bottoms of the hole. You can have air gaps where air was trapped at the bottom of the holes, and gaps all along the embedment depth of these anchors. Again, these samples were made using precise instructions from a major manufacturer by a well-experienced contractor in the San Francisco Bay Area. We've also made this plexiglass sample where we have inserted a precured dowel into one hole and then used floppy anchors in the other two. And although not clear in this picture, the fibers in the floppy bundled fiber anchors are twisted and bent and definitely not straight as one would want them to be in an FRP anchor. The next step is to take FRP anchors to field testing, and we think we have found a way to field test FRP anchors using the same equipment that is used to test metallic anchors in the field. This could be a really important next step for quality assurance for FRP anchors. We've gone ahead and developed installation instructions as well as checklists that a contractor can follow for installing FRP anchors. So FRP anchors are here to stay. We think precured FRP anchors is the right way forward. But in spite of the type of anchor that you use, there are some basic considerations that can be taken into account when specifying FRP anchors. It can be allowed that FRP anchors are designed by the FRP manufacturer, but certain requirements should be specified for any given project. It should be noted that FRP materials to make anchors should have tensile material properties equal to or better than the FRP being anchored. The minimum fiber content in the anchor should be specified. Testing done at University of Austin indicates that to fully develop a strip of FRP, i.e. to rupture that strip of FRP, you need twice the amount of FRP in the anchor. But for stream limits that are in ACI 440.2R, a fiber content of at least 1.5 times the strip FRP content should be specified. The hole should be radiused at where the anchor splays out, at least to a radius of half the radius of the hole. The anchor spacing should not exceed 10 inches. There is no testing that shows that higher spacings of anchors are effective. In fact, there's enough testing to show that up to 10 inches, the anchors will perform as expected. And then the splays of the anchor should be either put between layers or covered by FRP patches, preferably with FRP oriented perpendicular to the splays of the FRP anchors. With these simple specification items, there's a lot of quality control and design control that can be built into a specification. Finally, I would like to end with some thoughts on FRP anchors. As the use of FRP grows for seismic retrofit, it is clear that anchors are an essential tool in the design of such FRP. Since the seismic demands cannot be accurately estimated, it is important that some residual ductility be built into any design. It is clear that the current FRP anchor practices with the bundled fiber anchors have several drawbacks. Precured FRP anchors offer many advantages over what is being done right now. Using proper specifications, engineers and owners can ensure that certain minimum requirements for FRP anchors are built into their project documents. There has to be more emphasis on QA/QC in the field for FRP anchors. A design methodology has been developed to fully design FRP anchors. This design methodology should assist engineers in designing anchors themselves so that they know exactly what to expect for every given design project. And finally, ACR 440, of which I am a voting member, is now currently working on putting anchor design guidelines into the 440.2R document. Hopefully these new anchor design guidelines will be included in the 2022 edition. With this, I'd like to thank you for your attention.